Welcome back to Seacoast High School's remote trigonometry class. My name is Eric Fearing. I use he, him, his as my pronouns, and most of my students call me Mr. Today we're working on Competency 3, Benchmark 1, Part 1. In Competency 3, we're going to talk about what's called the unit circle, which is a diagram that relates triangles to circles, and specifically we're going to talk about how a circle can show us the sine and cosine values of angles today. A little bit more about this will make sense once we've talked about it a bit. So I've got a diagram here of a triangle in standard position on a coordinate plane. So our angle, theta, has one ray along the positive x-axis and another ray going out at some unknown angle. I just kind of drew this one. What I want to do first is just talk about the sine and cosine of theta. So we can find the sine and cosine if we know the opposite and the hypotenuse lengths and the adjacent and the hypotenuse lengths. So let's label that on this triangle. This would be the opposite side, this would be the adjacent side, and this is the hypotenuse. Now the hypotenuse here is also the radius of this circle that I've drawn. That's going to be important as we go on. But the hypotenuse being the radius of this circle means any triangle we draw to a point on this circle is going to have the same hypotenuse when we draw an altitude straight down to make a right angle with the x-axis. So here we're going to say that the hypotenuse is the same as the radius of our circle, and we call it the unit circle because it's convenient to say the radius is 1. What's your favorite number to divide by? Don't say 2, that wastes time. Dividing by 1 is the best. Opposite divided by hypotenuse with a hypotenuse of 1 just means that the sine is the opposite side. And similarly, the cosine of this angle would be the adjacent leg divided by 1. So that will divide out with no change, and that's why we use what's called the unit circle. So we would say that this point on the x-axis is 1, 0, and this point on the y-axis is 0, 1, to define that we have a radius 1 circle. So now we can see that the opposite side is this vertical leg, but this vertical distance is also, well, it's the distance from 0 up to wherever that is, which is also the y-coordinate of this point. So we sometimes say that the sine of an angle is the y-coordinate on the unit circle. Similarly, the adjacent leg goes right along the x-axis, and it goes from 0 to whatever value of x there happens to be. The length of the adjacent leg is the x value of that coordinate, where the ray of the angle intersects the unit circle. So, sine, y value, cosine, x value. That seems a little backwards. If we had a full course, I would try and get you in the concept here that as things go up and down, that changes the y value, and things going up and down is just a very important part of modeling how things turn, stuff like that. And things going side to side and back and forth is somewhat less intuitive, but doesn't make a big difference. Sine of an angle is its y value, and cosine of an angle is its x value if we're talking about the unit circle with radius 1. So what does this mean? We can draw lots of different triangles, but we're going to focus on the easy ones. We're going to draw a 30-degree angle and make our triangle. So because it's on the unit circle, we know that its radius is 1. And now If it's got a 30-degree angle and we've dropped an altitude along the grid lines, we would know that this is 90, and that makes this a 30, 60, 90 triangle. If you think back to your middle school or your geometry class, you might recall that 2, 1, and the square root of 3 is the ratios for the sides of a 30, 60, 90 triangle. We can also derive that from half of a equilateral triangle, which I think I did in an earlier video. But here we have a hypotenuse of 2. To make a similar triangle to this one, albeit tipped on its side, and with a radius of 1, we're going to need to divide all 3 of those and shrink it down to have a radius of 1. Clearly these are not drawn to scale. If we divided by 2, then we've got 1 as our hypotenuse, like we have here. Our short leg would be 1/2, and our long leg would be radical 3 over 2. So, what does that tell us? It tells us that the cosine of 30 degrees is exactly the square root of 3 over 2, the adjacent leg of this 30, 60, 90 triangle. Similarly, the sine of 30 degrees is going to be the height of this triangle, the y value, 1/2. This is one way to draw a 30, 60, 90 triangle. This is another orientation. I'm going to sketch another one on here. It's going to make a bit of a mess, I apologize. But we could put a, wow, among the worst straight lines I've ever drawn. There's 2 of them. So now we've got a 90-degree angle here, and let's say we had a 60-degree angle from the origin. Now we've still got a 30, 60, 90 triangle, but it's going the other way. And for this green triangle that's standing upright, I'm going to just redraw it over here for reference. We know the radius is still 1 anywhere on the circle. If we've chosen that to be the 60-degree angle, then it's next to the short leg, so the adjacent side is 1/2, and the opposite side is root 3/2, because these are all just different rotations and zooms, because we're just drawing by hand, of that same triangle. Which means we can say that the cosine of 60 degrees and the sine of 60 degrees are the inverted same numbers here. The cosine of 60 is going to be the adjacent leg, the x value. This is about halfway along the radius of the circle. It's 1/2. And the sine is root 3 over 2. So that's a 30, 60, 90 triangle inside the unit circle. We can also look at a 45-degree angle, because Pythagorean theorem tells us lots about when we know we have a 45-degree angle, it's isosceles. So we have a hypotenuse of 1, and we've got 2 legs that have to be equal to each other. We can solve a squared plus another a squared equals 1 squared and get exactly what these lengths are. I'm just going to tell you it's the square root of 2 over 2. You could also check out an old reference sheet from middle school where it would say root 2 was the hypotenuse and the legs were 1. Dividing by root 2 does funny things. I talked about rationalizing briefly in another video. Just stick to it. The square root of 2 over 2. So we're going to put all of those onto a circle again in the next video and sort of look at them all next to each other. But what we're doing right now is just noting that the sine of 45 degrees, let me do the cosine first. Cosine of 45 degrees is the x value, root 2 over 2, and the sine of 45 degrees is the y value, also root 2 over 2. So now we know the sine and cosine of 30 degrees, 60 degrees, and 45 degrees. Also going to point out one curious bit that's sort of a preview of the next video. If we drew a straight up angle had a 90-degree angle here, we wouldn't be forming a triangle anymore. We would just have a 90-degree angle. And we couldn't really say there's an opposite side and an adjacent side when we've got a 90-degree angle here and no third connector, right? Our hypotenuse goes straight up. It's got no width, really. Doesn't make any sense as a triangle. But it still has an x value and a y value. So we can now define the cosine and the sine of 90 degrees based on how far up this goes. And it goes up one whole unit, the radius of the unit circle, up. And how far to the right does it go? What is its x coordinate? Well, that's 0. One more piece. If we talked about over here, we could even take the cosine of 0 degrees and the sine of 0 degrees. And those would be the reverse, because this is to the right one whole, and it is not up at all. So, when you're asked to do this in the problem set, you're going to get a little drawing. I think it doesn't include the circle, but it does include an angle on a unit grid. I guess on coordinate axes rather than a grid. If we want the sine of 60 degrees, we just have to think about what we just did or look it up on a reference document, because that's not so tough. We just went through it. A 60-degree angle is going to go up like so. It's going to be a 30, 60, 90 triangle. We know it was 1 there, half there, and then the weird one, √3/2 there. The sine of this 60-degree angle is the y value of that point on the unit circle. The y value is the one that's going up. It's √3/2. So these are almost as easy as multiple choice, because when we've defined the sine and cosine ratios in terms of unit circle coordinates, we're just talking about the x and y values of the point on the circle where our angle would make that triangle. So the cosine is the x value of the point, and the sine is the y value of the point. You're going to be looking at common angles 30, 60, 45, 90, and 0, and just recognizing that you don't have to look them up anywhere else anymore, because we've just got a few things to choose from. 1/2, √2/2, √3/2, 0 and 1. All right, good luck with the 4 quick questions, and you'll see the next video soon.